That's okay. So sorry for the interruption, but the thing is, you can see my screen right now, right? No problems. Okay. So what I was talking about is the difference between DOM and SAX approaches. Data model. Okay. Data model. What we are talking about here is the XML data is transformed into navigable tree structure. Okay, in the memory.
Ravi, your voice is not clear.
I don't know why I'm facing so many problems today. In SAX and DOM, which is like a streaming API, like a simple API for XML versus DOM, data object XML. So streaming API, as we discussed before our interruption, is actually okay. It looks at sequence from top to bottom as elements, and whenever it sees an element, it has to do some processing. That is on an event based. Okay, whenever it encounters an element, it has to do some event handling code. That is what is called um, stream model or SAX. That is called simple API for XML. Okay, whereas in DOM we treat it in memory as a tree. Okay, and in memory as a tree, and within that memory we try to navigate it per each per each node. Okay, in our previous slides we saw how to represent it in a tree, right? So data is represented in terms of a tree, and each of these level is called a node, and within that node we try to capture the next node and stuff like that. And within the memory, if we maintain this kind of stuff, is called DOM. Okay, what is the difference between SAX and DOM? Now we should be able to talk about it, which is SAX is actually in sequence from top to bottom, and whenever it encounters an element, it tries to do some processing, which is called simple API for XML and or SAX. Whereas DOM, it represents it in terms of a tree in the memory, and whenever it encounters a node, it tries to do some processing. That is called DOM. Okay. So the problem with this kind of approach is it may need large amount of memory, right? Within memory, if you have big XML, there is always a possibility that memory consumption, like having a lot of data in memory, is always a problem. Okay, but may not be as fast as the stream approach. Some DOM parsers use SAX to build the tree. Okay, so that means here now you know the difference between SAX and DOM. Let's see here. SAX says like hard to get a global view of the document because you will be always focusing on element. Okay, and parsing state represented by global variable set by the event handlers. Okay, so that means when an event encounters, then only you can do some processing in stream model. Whereas in DOM, I'm repeating myself, so that means you got to be really careful when somebody asks you what is the difference between SAX and DOM. Okay, and may not be as fast as streaming approach because it handles it within the memory. Now let's see combined together. What is it? SAX and DOM are the standards for XML parsing. DOM is a W3C standard, and SAX is a ad hoc and very popular standard. Okay, so DOM is like a been prescribed by W3C. That's like a consortium, W3C consortium. Um, that's like a group. Okay, and there are various implementations available for both SAX and DOM. Okay, Java implementations are provided as a part of JAXP, which is called Java API for XML processing. So if you know SAX and DOM parsers, that means you know JAXP as well. If somebody asks you in the requirement, oh, do you know? Did you work with XMLs? Yeah, I worked with Java API for XML processing using SAX processor or a DOM processor parser and stuff like that. So you should be able to answer that. Okay. Then, difference between SAX and DOM. We've been repeating them ourselves, right? When we are discussing in our previous slides. Let's see more. DOM reads the entire document into memory and stores it as a tree data structure. SAX reads the document and calls the handler methods for each element or a block of text that it encounters. Okay. Consequences. DOM provides random access. That means within a tree structure, if you want to go to chapter N, you can directly go there. whereas with sax you cannot go, you have to go in sequence. That's one difference, right? And DOM is slow and requires huge amount of memory, so it cannot be used for large documents. Sax is fast and requires very little memory, so it can be used for huge documents. This makes sax much more popular for websites. If you are actually scraping websites and stuff like that kind of data, then you are going to use sax. Okay. Then parsing with sax. Sax uses the source listener delegate model for processing the XML document. What is it? Source is the XML data consisting of XML elements. A listener written in Java is attached to the document which listens for an event. When an event is thrown, some method is delegated for the handling of the code. That means whenever it encounters encounters an element, we will have a handler code. Okay. Then callbacks. Sax works through callbacks. That means the program calls the parser calls the methods provided by the program. So it's like a callback, back and forth. So that means, okay, main method, it starts the start of document, start element, characters, end element, and end document. That means you go invoke all these methods on the right hand side and come back to the main method. So that's like a callback. The moment you call parse method, you're going to do bunch of these stuff. That is what they're talking about. Okay. And simple sax program. Okay. The program consists of two classes. This class contains main method. It gets a factory to make the parses. Get the parser from the factory. Okay. Let me actually show the example. That's when probably you guys would be okay to follow. Okay. Let me actually go back to this example. Can you see my Eclipse? Can you guys see my Eclipse?
Yes, Ravi.
Yeah. So I'm trying to show you guys an example of Sax. Okay, Sax parser. Is it still difficult to see? Is it okay now, or do I have to move a little bit forward?
No, no, that's fine.
Yeah. Okay. So Sax parser, and I have an XML file called sax.xml. Let me actually bring that up as well. So this XML you guys are familiar right from the beginning. I'm showing you, right? So I have an XML. Sax parser. What I'm doing is I'm getting the factory. Okay. I'm reading the input stream. That means I'm reading the XML file as an input stream. And then in my, there is something called handler. Okay. I'm passing that Sax handler and XML input. That means uh, what I'm trying to do is, so any Sax parser will have a Sax parse factory, and you are going to read the XML file, and you're going to get the parser. Okay. And the parser has the parse method. That means processor method. It takes the input of the file that you want to parse, and it takes the handler, Sax handler. Okay. So if you just do this, it's going to process an XML and give it to you. Okay. And where does it set? It sets to your handler. Okay. Like whichever, it's like a new object, right? It doesn't have anything right now. You pass that to that. So that means you're giving it to Sax handler. Sax handler does all the things that you want and gives you back the objects. Okay. So if you look at this example, you have driver vehicle information. That means you have both driver information and vehicle information. If you logically look at this example, it has list of drivers, right? It has list of drivers, and it has vehicle IDs, and with each vehicle ID there is a vehicle object associated to it. Okay. So that means it's going to give us list of drivers. So what is this guy doing? This handler guy is actually setting list of drivers to it. Okay. Let's see what this Sax handler does. Okay. This Sax handler has, okay, start element, end element, list of characters encoding, and all this stuff. Okay. So what is it talking about? Okay. If you encounter something that begins with a driver, construct a driver object, and add it to the list of drivers. So I'm maintaining list of drivers here. Okay. So if you look at our example, we need list of drivers, right? Okay. If you encounter driver, so in our handler class, what we are trying to do? Start element. Okay. If the start element has driver, or if the start element has vehicle. See here, we have either vehicle that is starting as an element, or we have a driver that is starting as an element. So our handler code has start element driver. If it is starting with driver, we have to construct a driver object. If it is starting with vehicle, we have to construct a vehicle object. Okay, that's about it. Then within that, what we are trying to write is every element. See here, like every element. Okay, if driver ID, so get the driver object, set the driver ID. If you see a name and current element parent, like, see, it's just like we are processing, we are looking at an XML, and we are like, okay, if you encounter driver, construct a driver object. If you encounter driver ID and the parent is driver, then set driver ID to the driver object. Okay. If you encounter vehicle ID and the parent is driver, then go fetch a vehicle, construct a vehicle object, set the vehicle ID and name, something like that. So we are actually trying to construct everything by looking at each and every element and its parent. Okay, if you look at it, like, okay, we are trying to look at every element in it, and if the current element's parent is driver, we are trying to construct an object. Okay, like, okay, setting everything to driver object. If it is a vehicle ID and parent is vehicle, then we are trying to construct a vehicle object. Okay, so like that we go look at each and every element, and if the element is vehicle, we are going to close the vehicle object, like that. Okay, so if you just think about it like this, okay, it is extending some default handler, and you have written your sax handler here. Okay, you have written your sax handler, and you have your driver object, and you have your vehicle object. That means by looking at your XML logically here, by looking at your XML logically, you have a driver and vehicle information, and you need to, after the processing this particular XML, you need to get list of drivers, and within each driver you need to have like a vehicle information that particular driver can drive. Okay, so like that, by looking at XML, you need to know the logical structure of the Java bean that you need to construct, and based on that you're going to write your handler code. Okay, based on that you're going to write your handler code. So what is it doing here? It is reading the XML. Once you read the XML, you are putting your handler code in there. So sax parser internally invokes this handler and iterates to that start element, end element, and anything in between, and then gives us the handler object. Okay, that means this handler object has list of drivers, list of vehicles. Okay, so that means given a driver a vehicle ID, list of drivers has what? List of drivers has list of vehicles. Also, given a vehicle ID, you can fetch what vehicle we are talking about. Why? That's like a utility map that we are maintaining. If you look at this here, given a vehicle ID, you should be able to fetch vehicle object, right? So we are maintaining that map as well. Either you maintain it or not, that's up to you. But whenever you see a vehicle ID, you should be able to construct a vehicle object. That's the idea. Okay, so idea is at the end of the processing, you should be able to read the entire XML, get the list of drivers and how many vehicles, list of vehicle IDs that that person can actually drive. Okay, that person can actually drive. So if so you have the handler, like after this step is done, you have the handler logic which can have list of drivers, iterate through them and print out, okay, how we are reading it. That's the example. Okay, so let's see, let's run this example and maybe you can actually appreciate the concept probably. Let's see. uh, okay, see here, it says data slash sas sax hyphen xml example.xml does not exist. Why is it saying that? If you look at it here, I have data in here, sax hyphen sample, right? But it's not able to find it. Okay. Data hyphen no such file or directory exist. Okay. So sax hyphen example exists, but it says it doesn't exist, right? So that means it's not part of our this one, um, not part of our class path. Probably. Let me actually try to do something in here. Or I can actually give um, qualified. Either ways we can run it, right? I can give the entire this one, or if we just want to give this one, let me actually do something a little bit different. um, I want to add that folder also as part of class path. Okay, let's probably see if I can do anything in there. If it still throws error, I'll give absolute path. Yeah. So no file or directory data hyphen this one. I'll just give absolute path. That's okay. Okay. Still it's throwing that error. What is its problem? No such file or directory. Sax example file. Huh. Sax hyphen example file. Is it right? Sax hyphen example.xml. Huh. Why is it not able to find it at all? Huh. No such file or directory. That's weird. File not found. Why? Users are, is it incorrect? Users this Java 11 probably is causing the problem. It's there in here, right? Okay, let me actually type here. See, that didn't make sense at all to me. Example. We did bunch of stuff like this in IO operation, right? Hmm. I don't know why. Okay, so at this we read this particular thing handlers. See here, after this is done, we have a list of objects. Okay, so John Doe can write limousine, or Aston Martin or Joe Blocks can ride a bus. Okay, so that's how it constructed, because in our sax handler we put bunch of stuff in here, like start element is this, push and all that. We constructed the object in such a way and all that, and finally it prints out whatever this guy had. Okay, like if you look at your sample, like if you look at the example first. Okay, John Doe can ride a limousine or Aston Martin, right? So that's how we are actually trying to get the list of drivers, and we are trying to print them off. Okay, okay. Did you guys follow, or any questions? Did you guys follow? Any questions, like how to write a sax handler, or like what exactly this is doing? Any questions, or did you follow how it is doing it? Like we're trying to read the XML and look at each and every node, and trying to construct it. So let me know if there is any problem in understanding that. Okay, then, so that's what we're talking about here. The program consists of two classes. It gets a factory to make parsers, get a parser from the factory, creates a handler. Now it makes sense, right? Creates a handler and tells the parser which handler to send its callbacks to. That means um, like a start element, end element, and all that stuff, and reads and parses the input XML. So, and handler, what does it do? This class contains handlers for three kinds of callbacks: start element, end element, and character callback, generated for the content of the element. Okay, then a sample class, similar to how we did. Okay, we're going to parse that, and the parser reads the file, and it should be located in the same directory. Okay, then the handler class. Handler class extends the default handler, and we'll have three methods that we are going to override. Okay, and start the element. So how does the start element behave, and characters, and so this is what we saw, right? So this is one other example in the slides. Okay, factories. Sax uses a parser factory. It means a factory is a design pattern alternative to constructors. You guys know constructors, right? In the same way, factory is a design pattern. We'll talk about it in design pattern class more, but Factory is a design pattern to construct objects. It's a factory to construct objects. And factories allows the programmer to decide whether or not to create a new object all the time and decide what kind of object to create. Okay, you will tell them, tell the factory like, okay, I need a trust object in this case. It's going to look at it and whether it has to create it or not, it will decide and give it back to us. Okay, whether to construct an object or not. Okay. Parser factories. To create a sax parser factory, call the static method like sax parser factory dot new instance. That's going to actually deal with it, like whether it has to, if there is an instance already, it may give it back, or it may actually create the new instance. Okay. And if you want to know like a namespace is there, you are going to set like a namespace aware. That means it has to validate the namespaces. Okay. Getting a parser. Once a sax parser factory was set up, parsers can be created with this one, sax parser factory.new sax parser and sax parser.get XML reader. So you can read an XML file. Okay. Declaring which handlers to use. That means what kind of handler you want to have, like either your custom handler or a default handler. You can tell them. Okay. Here we used sax handler, right? In the same way. Then Sax handlers. A callback handler must implement four interfaces: interface content handler, interface DTD handler, entity resolver, and error handler. That means internally all this is being done. Like if you see here, look at your Sax handler. So it's extending a default handler. That means the default handler guy should already be doing what they are talking about. It is implementing entity resolver, DTD handler, content handler, and error handler. Okay, so that means if you just extend the default handler, you're good. Okay, that's what they're talking about. Like a callback handler must implement four interfaces: content handler, DTD handler, and entity resolver and error handler. Because if there is an error, somebody has to notify you. If it has to be resolved to an object, somebody has to resolve it to an entity. Entity is nothing but a bean. Okay. And DTD handler, like anything like any rules that it has to implement should be by DTD handler. Any DTD that it has to invoke. Okay, content handler. That's where we have this character something, right? Characters thing. So this is something from the content handler probably. Okay. Class default handler. Okay, this is what we're talking about. This class default handler is in an adapter from is an adapter. That means in between all these interfaces and in your original handler, there is an adapter. That means it is bringing in everything. Adapter is nothing but a pattern again, design pattern. Okay, so that adapter pattern um, actually helps us in implementing all the handlers, and that is taken care of. And if you just override the methods that needs to be overridden, you're good. So what adapter does, whatever you need to implement are all been hidden from you, and yeah, it's going to give you some methods that you need to override, and if you just give behavior to those, you're good. Okay. Content handler methods, again they're talking about all the various methods that content handler can give. Okay, so these all help in iterating through your content. Okay. In error handling methods like fatal errors, like serious errors, and warnings and all that. External parsers. Alternatively, you can use an existing parsers. Like you need not write your own parsers, like just like how you did for sax handler. You need not do everything on your own. Okay, there are already good APIs that are available, like sarses, and um, expat expat and all that stuff. These guys are already implementing all these sacks and all that. You can just import that jar and use it. Okay, you need not do reinvent the wheel. You can just use any of these guys. Okay, then so this is one other example like how to use this parsing. Okay, this is a web application using sources. Okay. Okay, problems with Sax. So far we saw all this is all simple API for XML, right? What are the problems? SAX provides only sequential access to the document. Okay, SAX provides only sequential access to the document. So SAX has only a local view of the current element being processed. Global knowledge of parsing must be stored in the global variables. So always it knows more about the current element. If it has to be like you need to get a global picture, you need to maintain it in the, like you need to be constructing the global knowledge parameters as well to get the full picture of the entire XML. Okay. A single start element method for all elements. In the start element, there are many if and else conditions. We saw that, right? That's a problem. Like it's like a bunch of if and else. And if you are writing bunch of if and else conditions, there's always a scope for errors, right? You may miss some if conditions. So there is always a scope for errors. That is one disadvantage of it. Okay? When element is seen, a global flag is set. When finished with the element, global flag must be set to false, which is like cumbersome. It cannot be like thread safe if we are doing it on our own. DOM represents the XML document as a tree structure. We talked about it, right? So hierarchical nature of tree maps well to hierarchical nesting of XML elements, like how we saw the tree structure. And tree contains the global view. So at any point of time, you can go to a particular node that you are of interest and access that particular thing. So easier processing than SAX, but memory intensive. You got to put entire thing in the memory, right? So it's like each of it has its own advantages and disadvantages. It's up to the requirement that you are trying to address. If memory is not a concern, you're going to put everything in the memory, like depending on the size of the file. If memory is a concern, you're going to use SAX. Okay. And as well as SAX and DOM is an API only, does not specify a parser. DOM parsers typically use SAX parsing. That means internally they use SAX is what they are talking about. Okay. Simple DOM program. Let's see how to execute a simple DOM program. Okay. So this is the DOM parser, and we're trying to read a text.xml here. If you look at this one, um, if you look at this XML file, okay, if you look at this XML file, it has company and staffs, list of staffs, right? And you can have like staff by name as each node, right? So the moment it hits a company, it's going to construct a company object, and within that you have list of staff. Okay, so what is this DOM parser doing? Let's see. It's reading the file. It's using document builder factory. In SAX we saw it is constructing SAX builder factory, right? Something like that. And SAX factory, or yeah, and it's building the build. It's using the builder, and it says like parse the file that you are interested in. And once you did that, that's it. You got everything in memory. You got the document, entire document in the memory. Now whichever element you are interested in, you can access it. Okay. Now whichever element you are interested in, you can access it. Okay. Like everything is an element within it, and you can get the values out of it. Okay. So it's easy to implement. If you look at did you guys feel the same way? It's easy to implement, right? Not much of handling code that you need to write and all that stuff. But everything, the moment you call this step, everything came into the memory. Okay. Okay, let's see how to execute this. You know what? That was all Windows when I created these examples. Probably if I do this, it will work. Okay. So it parsed. See, document is null. It could not find anything probably. Let's see. Oh, it found it. Okay. Company. See, it read everything. Like you have everything as elements within it. Like each of it is a node, right? So within the node, you are getting each and every element. Like if you look at this particular example, company is a node, root node. And within that root node, you have a bunch of stuff like next element is a staff and next element is staff like that. Okay. Okay. So this is just a utility method that we have written for ourselves. Instead of repeating this code again and again, we have written a utility method. Okay. So this is DOM. Okay. Sax and DOM. One we know the difference now. Like one has to deal with in the memory as a tree structure, and the other one is going through events sequentially. And Sax has a Sax builder factory and all that stuff. DOM has DOM builder factory. Okay, and you are going to iterate through them as nodes. Okay, so reading the tree and structure of the DOM tree is like, look at that sample. Like you're going to get the node name, node value, node type, node attributes, and all that. So the moment you call that parse method, you got the entire document and you iterate it through however you want. Whichever node you want, you can go directly. Okay. Then distinguishing node types like element node or text node or attribute node, you can have a switch case and identify it. Okay. Right. Operations on nodes, you can get the parent node of it. That means if it is a staff, parent node will be a company, like that. Okay. So you have a bunch of utility methods that help identifying them pretty fast. Okay. Get attributes. Pre-order traversal. The DOM is stored in the memory as a tree. So trees can be traversed using pre-order, in order, or post-order. If you are from data structures background, you studied data structures. Pre-order is like the one on the left-hand side will be taken into account first, or the one on the middle will be taken into account first. Post-order is like one on the right-hand side will be taken into account first. So that's like a simple way to traverse a tree is in pre-order. That means left to right. So the general form of a pre-order traversal is the visit the root, traverse each one of the subtrees in order. In order. Okay. So simple pre-order. Okay. Instant. So has child nodes. So we print all the child nodes. Get the first child. Okay. And then simple pre-order. So that means we are going from top to bottom and left to right. Okay. This is like a pre-order. So novel, here what we are trying to try out the program. So what we are trying to do, we have a novel and chapters. Okay. And number one is the attribute, number two is the attribute, number three is the attribute. Okay. So you just iterate through this and print it out. Like, okay, number one, root is novel. Then what? You want to go to the text three. Okay. And like if you want to go to last element, you can print it out directly. Right. So print out the content of it. Okay. Things to think about are, what are the numbers? Are the nulls in the right place? Is the indentation as expected? How could this program be improved? Like when you are actually printing it out. Okay. So overview. DOM, unlike Sax, gives allows to create and modify XML trees. There are three basic kinds of operations: creating a new DOM, modifying the structure of a DOM, modifying the content of a DOM. Okay. Creating a new DOM requires a few extra methods just to get started. So afterwards, you can add elements uh, through modifying its structures and contents of it. Creating a new DOM. That means writing an XML file. Okay. Actually, reading and writing. We can do both, right? With these XMLs, that is what we're talking about. So when you're writing it, so you're going to construct like new instance, new document builder, and you're going to construct a new document. That means you got a new document. Now you're going to add nodes to it. Okay. add a root node, add child nodes to it, and all that stuff after this step. Okay. So the following are the instances of methods that helps you in create an element namespace, create attribute, and all that stuff. Okay. Then methods of the node. Within each node, you have append child, insert before. Like you have methods like, okay, in a tree structure, you want to insert something before, you want to remove a child, you want to replace a child, and all that stuff. So methods of element. So within an element, you have a bunch of stuff like attribute values. Like element will have attributes, right? Like this one. Like if you go back here in our example, this is an element and it can have attributes, right? So that is what we are talking about. Okay. Or all this stuff can be actually put it as attributes in staff. Okay. Methods of an attribute. You can set value and all that. Writing out the DOM as an XML. So there are no Java supplied methods for writing out a DOM as an XML, but you can actually write that DOM yourself. Like writing out a DOM is conceptually simple. It is just a tree walk. That means you construct the entire DOM builder, you construct the entire document, add all the nodes that you want, and you just spill it out as a string. Okay. You just spill it out like a string. Streaming API of XML. Okay, so this is something new with Java 5.0 onwards. Like you saw Sax, you saw DOM. Those are like predominantly great parsers, and very important interview question difference between those two. Now we are looking at streaming API. What is the streaming API? Streaming API for XML called Stacks is an API for reading and writing XML documents. Stacks is a pull parsing model. It means application take the control over parsing the XML document by pulling the events from the parser. Okay, that means pull parsing. So application take the control over the parsing XML documents uh, by pulling the events from the parser. So it pulls out like similar to Sax, but a little bit advanced is um, application can take over the control, and it can pull whichever event that it wants from the parser. Let's see. This text, maybe I took a screenshot from somewhere. If it is not very clear, I'll try to adjust it. But for now, just if you can listen to me, that would be great. If it is not clear to you, Sax, which provides an event-driven XML parsing processing, right, follows the push parsing model. Okay, Sax we saw, right? That is event-driven. That means if a particular event happens, that's when we go to the handler code. That is called push parsing. That means an event happens. That's when we go for the um, event handling code. What this model means is that in Sax applications will register listeners in the form of handlers to the parser and will get notified through the callback methods. That's what we saw, right? Here the Sax parser takes the control over the application. Okay, application will wait and Sax parser will take the control over the application thread. So Sax is a push parsing model, whereas streaming API for XML is a pull parsing model, means that application can take control over parsing the XML documents by taking the events from the parser. The disadvantage of DOM parser is it will keep the whole XML document in the memory. We saw that, right? And certainly this would be problematic if the size of the document is large. So streaming API for XML does not follow this type of model, and it also has options for skipping a portion of a large document during reading. That means it is like a stream, and we are actually pulling whatever events that we need, and we may skip whatever we are not interested in. Okay. Then the core streaming API for XML API falls into two categories, and they are listed below. They are cursor API or event iterator API. That means cursor is nothing but you can have a cursor of all the events that you have, similar to Sax, or you can iterate through them based off of events. That means, okay, what is the next event? What is the next event? What is the iterator, right? In the collection we saw. In the same way, you're going to maintain an iterator of it. Okay. Let's see. Streaming API for XML. The cursor API is used to traverse over the XML document. Think of a cursor as some kind of pointer pointing at a start of the XML document and then forwarding the document upon properly instructed. So the working model of this cursor API is very simple. When given an XML document and asked to parse, the parser will start reading the XML document. And if any of the nodes like start element, attribute, text, end element are found, it will stop and will give the information about the nodes to the processing application if requested. This cursor is a forward only cursor. That means it can move only forward. It cannot go backward. It can never go back. Both reading and writing operations is possible in this cursor API. And then streaming API for XML, like we are talking about the working model of an iterator, event iterator. So working model of this event iterator is no more different from cursor API. As the parser starts traversing over the XML document, if any of the nodes are found, it will provide this information to the application that is processing in the form of XML events. Application can loop over the entire document by requesting the next event. This event iterator API is implemented on top of the cursor API. That's what we thought, right? Like, okay, you have the entire list of events, and on top of it, you will have like event API. That's like a wrapper. Okay, I am interested in only the events. If you don't have an event, or if I want to skip an event, don't give it to me. So it is on top of cursor API. Okay, so let's see the examples of these. Okay, so let me go back in here. Streaming API, right? So here, let's see reading using a cursor API. Streaming API. Okay, here, let's see. Okay, so what is this guy doing? It's becoming really difficult for me to actually zoom in. Okay, streaming API, right? Okay, so here, okay, test read. What is it doing? Stacks parser. In the stacks parser, it's our class that we just saw. Okay, what we are doing is read config, and we're passing the config file. And what does this config file has? Let's see. It has config is the root, item, three items. It has three items, right? Okay, let's see that. Three items. Okay, and once we have these three items, when it says read config, let's see what it is doing. When it said read config, what is it doing? It is reading the file as an input stream. It's creating XML event reader. Okay, XML event reader. That means it has a method. It is going to fetch only the list of events. Okay, this is like a cursor. Okay, like event iterator on top of a cursor. Okay, so iterator has what? Has next methods. If you guys remember, in our collections we saw that, right? So it is fetching each and every event. Okay, and that event start method and end method and all that stuff. And if you are not interested in one of those events, you can skip. Okay, if you're not interested in one of those events, you can skip. That's the idea. Okay, if it is a start element, you're going to do something. Okay, if it is a start element, you want to set some mode, some event, some unit, current, interactive, and all that stuff. Okay, so if it is an end element, you're going to close probably. This is like crazy. Okay, if it is an end element, you're going to actually close. Okay, by the end of it, idea is you construct the list of items. Okay, by the end of it, your idea is to construct the list of items. So if you go back here, you get the read config list of items, and you're going to display the list of items. If you look at our example here, all you need is list of items. So we constructed the list of items. And how did we construct? It's easy, not cumbersome code like SAX, right? In SAX, you got to do a bunch of stuff, event handling code and all. It has all the event handlers. All you're caring about is, okay, if it is a if starting element is item, you want to construct an item object. You want to set bunch of details to it, right? So this is what we are just checking. Okay. um, and if you are not interested in a particular event, you can skip. That's the idea. And it is called pull parsing. What is the difference between streaming API and a SAX? SAX is push. That means application will stop and the parser code will take the control of your processing of XML. Whereas streaming API is pull parsing. Okay, that means application will take the control of the parsing code. That is pull parsing. Okay, this is the main difference. And then reading using cursor API. We saw event just now, right? So similarly, see how we use a cursor API. Okay. So you have a calendar and list of events like a meeting, birthday, and all that. So how this cursor API works? So you have a read cursor API object.read, and the moment you said read, it is reading the XML, and within that you have has next and everything. So previously, if you see the method difference here we are just saying create stream XML stream reader. Okay. Whereas in the previous example, in the test read, here we are just saying create XML event reader. Okay. In the cursor, you're going to get the entire stream. Whereas in here, you're going to get only the events. Okay. That way, that way you're going to get only the events. Okay. Whereas here, you're going to get the entire stream of the XML. Okay. Entire stream of the XML. And all you're doing is type of that event. Maybe it is a character, attribute, and all that. And you're going to do the same stuff. But here you get a handle of the entire XML, whereas here you're going to get only the events. Okay. Here we're going to get like, okay, event data start element. Okay. And if it is a start element, we do a bunch of stuff. Okay. If it is not, we don't do a bunch of stuff and all that. Okay. So it's just various representations. Either you want to get the event or you want to get the stream. Okay. It's going to give you a bunch of XML event objects, whereas this guy is going to give a bunch of, this one is going to give the entire XML reader. Okay. Stream reader. Okay. And then how to write. So we saw read and we saw, let's see, write. So you're going to get the config.xml and you're going to save the config. And how to save, you're going to write like, okay, you read the entire events and you're adding bunch of more stuff to it. Like on your own, you're creating nodes and you're adding it to the event factory, creating an element and writing it back. Okay. That means not only just reading, you can add bunch of other stuff to write as well. Okay. Bunch of other stuff to write as well. And if you see in our slides, so what is the difference between these two? So event iterator is no different than cursor as the parser starts traversing over the XML document. And if any of the nodes are found, it will provide this information. If none of the nodes are found, it will not provide any information, event handler. Whereas this guy can even provide the empty. See, cursor API gives the entire XML structure. Okay, nodes are found. It will stop and will give the information about the nodes to process application if requested. But if here, if any of the nodes are found, it will provide this information for the application processing. If none of them are found, it will not give anything. But here you still have the handle of the entire XML document. Whereas here you don't have the handle of the entire XML document. That's the only difference. Okay. And you can also write XMLs. We can just execute this one as well, probably. Let's see. Save config is going to read config file. Where is the config file? Let's see. Let's try executing this one last one. Okay, see, it created a config.xml. Okay, how it got this information? Model, unit, current, interactive. Because in your test write.xml Java, you said I need a config.2, config2.xml, and within the save, you are actually creating the event factory, creating the document. Okay, creating the document. You put, okay, I need one as unit, one as mode, current, interactive, and all that stuff. And you said it all should be in config. Okay, so config is the root. Okay, it all should be in config. So config is the root, and you have mode, unit, current, and interactive. Okay, so this is how you are going to write. Okay, and if you want to write using streaming API for XML, here, so let's see what is the difference between this one and the other one that we have written, right? Test write is there. Here we are using streaming API for XML writer, and here also we are using the same. Okay, what is the difference? Why do we have two examples? Let's see. Oh no, this is a streaming API. Let's see. Test writer is also using stacks writer. Oh, okay, then we are good. Actually, we are talking about the same thing. I think, yeah, I think we are talking about the same thing here, here and here. Yeah, yeah. So that's all about streaming API, and XML parsing and DOM parsing. You should be able to answer what is a stream. Like if you go back to our this Excel, ah, if you go back to our Excel here, you should be able to answer these questions, right? What is an XML? Okay, can one of you answer what is an XML? Like, did we cover everything? Like, what is an XML? What are XML parsers? Types of parsers? Why do we use parsers? And all that stuff. Okay. So, can one of you talk about what is an XML before we wind up?